when it is a very expensive metal alloy. That is the disc, basically it is a platform. And over this platform, we have to place the sample and the reference material on this raised platform. And this sample and reference both are in the same zone. But in case of power compensated DSC, there are two different zones. Sample in different zone, reference in different zones. But the heat flow should be in the identical and the equal rates. So in case of here, so chromyl wafer, aluminum wafer, chromyl wire, most of these metal alloys, they are highly, basically, these are, yeah, this one. So mostly this chromyl, that is alloy of nickel and copper, and Constantan area, chromyl, aluminum alloy, 95% nickel, 2% manganese, aluminum and silicon. These are thermocouples generally used. Thermocouple basically it is a junction between two different metals which produce a voltage due to a temperature difference, that is delta T. So furnace here, but it is a very important point in case of DSC, one block for both the sample and the reference. But in case of power compensated, there are two blocks for both sample and reference individually. And temperature controller and the rest of the things remain similar. So here the sample holder, it is made of the platinum pan, and mostly, and sensors mostly it is made of the platinum thermocouples of platinum metals. So here, and I think this is a very important slide, because this cell basically consistent, this Constantan disc, and this it is a alloy which of nickel and copper, and this Constantan disc provides the heat, transfer the heat to the sample and the reference material. The sample and reference material are placed in a separate pan, which is sit on the that is the Constantan platform. This heat is transferred to the sample and reference through the help of disc, Constantan disc. And this differential heat flow, that is called this delta H, basically, the heat flow to the sample and reference is monitored by the Constantan thermocouples, which is formed at the junction of the Constantan disc, that is the in between. These are four wires are there, basically that is the central joints. And these chromyl and aluminum wires basically connected to the underside of the wafers to the thermocouple, which is directly used to monitor the sample temperature. So these are the alloy, and here this is the temperature range of this one, minus 170 to 750 degrees centigrade. So that is the only problem when we compare about the DTA systems, because in DTA the temperature range is up to 2000 to 2400 degrees centigrade. But in case of DSC systems, this temperature is limited by up to 800 degrees centigrade. But minus scale is almost similar as compared to DTA systems, minus 170. Sample size remains similar in case of DTA and DSC, that is 0.1 to 100 milligram. So that is the again application of DSC. So mostly I think most of the industries, and particular whether it is food industries, cosmetics, ceramic industries, material industries, catalyst industries, polymer industries, all these provides the basic unit, they have DSC systems. So without the DSC, their studies cannot be fulfilled. So it is the basic component of mostly in research labs, which are particularly working on the materials, either the catalytic materials or the that is the electrode materials or the for the electrochemical applications. Mostly this DSC is very useful, and, because it is again you can study the kinetics of the reaction of the process. So only here because whatever the thermogram is there under the area under the thermogram is that the proportional to the heat capacity of the material. So again, these are some important applications related to this only pharmaceutical industry. So mostly in pharmaceutical industries, they are utilized by for the study of protein stability, folding, liquid pharmaceutical formulations, process development, protein engineering, antibody domain studies. So mostly these biological studies for the samples can be done by this DSC. So it has a great application, wider applications in pharmaceutical. So again, this is we have summarized some important point, because what is the basic difference between all these three techniques, TG, DT, and DSC. So DT generally mostly we have to compare this delta T with respect to sample temperature. In DSC, basically it is similar to DTA, but due to a more sophisticated construction, we not only that is count delta T. In addition to delta T, we also observe the heat capacity of the materials. TG we have studied that TG can only measure the weight loss with respect to temperature. DT-DSC provides the useful information about the materials. Only phase transitions or any heat capacity or the change in phase materials can be studied. So, but DSC and DAT is the basic difference because DSC is a calorimetric method, so it provides the heat flow, or directly we can calculate the energy associated with the phase transitions. But in case of DTA, we cannot, because DTA is a simple thermal technique. DSC is a calorimetric technique, so heat flow cannot be calculated by DTA. So here we have summarized some good practices for thermal experiments. Suppose we have any unknown solid materials or the non-volatile materials or any materials we want to characterize with respect to thermal application point of view. So before running any sample on the DSC system, the first preference, run that sample in the TGA system. Because if any sample is unknown, you don't know the chemistry of that material, how it is happening. Maybe sometimes this material, high energy material is there, then maybe this will exploit the DSC cell or DSC system. So before getting any information or the experimental condition for a unknown sample, first we run that sample in a TGA. So but this TGA, that sample should be run in TGA in different environments. Then by using this different thermograms, we will get some important experimental conditions for the DSC system or DTA systems. So this is a very important point. Direct, don't place any, because DSC is a more sophisticated and highly sophisticated systems, and because it is also associated high maintenance cost, because liquid nitrogen is associated with DSC, and the liquid nitrogen cannot be stored for a longer period. So again, it is some maintenance issues there with respect to DSC system. So first we run that sample in TGA, then we will get some experimental observations for the DSC system. Then we will go for the further characterization in the similar way. So I will highlight the last, that is the point, how we can characterize, how we, that is utilize this DSC for the analysis of this magnesium oxalate dihydrate. So here we will show this DSC diagram. So here this is a TG-DSC system. So here the same material, already we have studied the TGA. It is a two-step decomposition process. But when we go for the DSC analysis, then we will get, this is a 1, 2, and 3. Then this is the 3 types of peaks or the phases changes or the material changes with respect to reference will be observed. So this is it is important. We can characterize whether it is a calcium oxalate or magnesium oxalate by utilizing this DSC technique. We can compare. So, and sometimes, but right now most of the hyphenated and advanced instruments, they have coupled with this TG FTIR and this DSC FTIR. So they have, but it is again, it is a research issue. So this technique should be coupled with this type of analysis. So TG, it is coupled with the FTIR right now. So you can get with the characterization of the material with respect to, at the same time, the functionality of the materials can be characterized. So again, this is a R&D, that is the research and development, advanced developments in the instrumentation part. So I will discuss, this is the last topic of this discussion talk, that is the Dsc Thermogram of dolomite. Why we have considered this material dolomite? Because it is also known as dolostone. It is a very important material for the construction industries. Dolomite. So dolomite are mostly used in cement or for making the cement or this mortar for the construction point of view. But the problem is this, because the dolomite is the industrial, that is product, but dolomite it is a white stone material. It is a carbonated rock material. But right now, what will happen, because mostly, particularly in India, this dolomite basically it is mixed with the calcite. Calcite is again, it is a white powder. So calcite again, because calcite is a calcium carbonate. It is the cheaper as compared to dolomite. So what we compare? So most of these manufacturers or the persons who are working in this material industry sector, they have simply this. We have taken the 10% of dolomite and that is contaminated with the 90% calcite, because both are looks like similar. So so we can easily characterize the purity of this dolomite by using this TG and DSC systems. So it is a very versatile application of this TG and DSC. On the basis of this instrumentation, we can simply characterize our materials, whether it is contaminated or it is a pure one. Based on that, the price of that material can be estimated in the market. So again, I will discuss in the coming. No, please. Yes, we have highlighted some important points related to this DSC system. So dolomite is also known as dolomite dolostone. It is basically a double carbonate of this calcium and magnesium. So it is a calcium carbonate and magnesium carbonate. So in I think Indonesia, that is the East Java. Basically, it is the leading producer of dolomite in the world. And again, this dolomite is a precursor for the production of magnesium metal. So, but it is mostly used in the cement or the construction industries.
Okay.
It is very chemically similar to the calcite, but here the physical properties of both the metals very significant. So, because the only the physical appearance of this calcite and dolomite, the most of the persons so they have mixed with this dolomite with calcite. So, on the basis of TG, DT, and DSC studies, we can characterize whether this material is contaminated with the calcite or not. So this is the importance and the significance and of this thermal techniques to characterize the purity of the materials. This way. So here, this is the Pgbs thermogram. It is a little bit complicated. So in the top, this curve, that is the that one. Basically, it is source TG and DTG curve, but this TG and DTG curve in different environment. One in CO2 and another is nitrogen. In the similarly, in the blue, that is the part that is the light blue color and the black color curve. Basically, it is the DSC curve. So this DSC curve basically it is recorded that is the 1 watt per gram of the sample. So this is the DSC curve, and this is the TG and DTG curve. So on the basis of this curve, we can characterize this. So it is very, if you go for this analysis, DSC curve, I think it is a shows there are one endothermic peak, and in the another case there are two exothermic, sorry, endothermic peaks. So I will discuss that is the significance of this one. So this when dolomite is heated in the nitrogen environment, when DSC displays that it is single peak. So if you go for that in nitrogen, so that is a black one. So it is a single peak. When we go for this that is CO2 environment, then two peaks. So when it is heated in the CO2 environment, then there are two endothermic peaks will be observed. So why this is two endothermic peaks will be observed? Because mostly because here the environment is the CO2. So definitely this calcium, double carbonate of calcium and magnesium basically decomposed into two different decarboxylation reactions at two different temperatures. So first decarboxylation reactions happens at 750 degrees centigrade, and the other decarboxylation reactions happened on the I think 850 degrees centigrade. So, but there's this first reaction, it is not a reversible in nature, but the second decarboxylation reaction is reversible in nature. So, why this reversible? Because here the CO2 partial pressure plays a very important role. So, because here the CaCO3 nothing, it basically it is a calcite. It is a pure calcite. So, if your sample is contaminated this calcite, then definitely these reactions will be more. The area of that DSC curve under the DSC thermogram will be more. So on the basis of that, you can easily find out what type of contamination is there or not. So this is the significance of these DSC systems to find out this the identification of two similar types of carbonated minerals. One is called calcite, another is called that is basically dolomite. So they are basically physically appearance have similars, but the chemical compositions and physical properties vary significantly. So finally, we can, with the power of this thermal techniques and the versatile that is nature of these TGTSC systems, we can easily distinguish between chemically similar carbonate materials like calcite and dolomite. So this is the this is the last one. So these are the some references which we have taken for the preparation of this presentation. That is, I think, most important books. That is the Dsc that is the for analytical chemistry, and there is Valiard, and there is the David Harvey. That is a very important book for this analytical chemistry. And the last book is basically it is a Indian author book. It is easily available in the market, and all these first three books are basically it is a I think we can say the very renowned books for this analytical chemistry. So from my side, it is over, and thank you for your presence. If you have any questions, please let me know.
Thank you so much, sir. Thank you for your valuable suggestions and support. It's a great pleasure for all of us to listen to you. Now the session is carried out with the question answer. So open for the question. You can raise your hand if anyone is having any question.
Excellent presentation, sir.
Yeah, thank you, ma'am. Thank you so
I
much.
just want to know
Thank you,
about
sir.
the reference compound. Reference, what is the properties of the reference?
Reference material, the most important property, the materials does not go any thermal decomposition. So alpha alumina, it is the best reference material for considering in DT and DSC application.
Yes, I
Alpha,
just wanted to know it.
yeah.
Thank you, sir. Thank you, sir.
Thank you, Neena ma'am. Any other question, please?
Excuse me, sir.
Yeah, please.
Sir, actually, I want to ask that if I want to study the thermal stability of polymeric materials,
Okay.
then what I should measure, glass transition temperature or melting temperature?
No, no, actually, madam, if you go for the polymeric characterization point of view, so for any polymeric material, if it is heated in the first, that is the temperature, definitely it will be converting into the glassy state.
Okay.
So at which the material is converting into the glassy state, the temperature is referred to as the glass transition temperature.
Okay.
So and after that, what will happen when this glassy material is further it is heated by the furnace, then it is converting into the little bit molten states. So on
Okay.
that time, we can consider the melting temperature of that polymer. If we go for the further, that is the heating, then this material will decompose. So
Okay.
melting temperature is the last temperature which is observed in DSC systems for the polymeric material.
Okay. Thank you, sir. Sir, one more question I
Yeah,
have.
please, please.
So can we perform TG and DSC of same sample in different atmosphere? So with different atmosphere, we get the same result or we get different results. If we first we use nitrogen and then can I use carbon dioxide also? So
Okay,
we
okay. Madam,
yes.
problem is this because the DSC principle is different and TGA principle is different.
Okay.
They cannot be coupled with the TGA and DSC, but the same material can be analyzed in TGA separately, can also be analyzed in DSC separately.
Yes,
Environment
sir.
may be different. There is no problem.
Sir, actually, the question is for both. For example, if I want to perform TGA only, so
Okay.
for same sample, can I perform it in nitrogen atmosphere as well as in carbon dioxide
Yeah,
also?
yeah, definitely. With the help
So,
of some external cylinders, if you want to maintain this nitrogen environment, you can supply the only nitrogen gas and stop
okay,
the other gases. If you want to utilize the thermograms in CO2 environment, so supply the CO2 environment in the furnace. There is no problem.
so
Same
we get
material
this,
can be analyzed.
we get the same results or
No, 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 madam. No,
different
madam.
results.
Results will be different.
Okay, thank you, sir.
Why different, sir?
Yeah, mess problem है because in that is nitrogen medium, that is the inert medium. Yeah. Hello? You are getting my
Yes, sir.
point? Yeah. In
No,
nitrogen medium, it is inert medium, madam. So there is no any that is oxidative reactions are not possible in the material. But when we go for the CO2 environment, then this is a reduction environment is there. So if any that is the reactions, which is any material, if you have the characteristic of the reducing atmosphere, then definitely the products will be different. So the decomposition of that material will be different.
okay, sir. Comparison can be made.
Yeah,
Just
comparison
for
can be made
comparison.
from the nitrogen and from the reactive environment.
Yes, yes.
Thank you. Thank you, sir. Thank you so much.
Sir, these instruments might be very costly, very costly.
Yes, ma'am. TG, I think little about 8 to 10 lakhs, but DSC system is more expensive as compared to DT and TG. Because the requirements, the maintenance, again, it is a very expensive part. So the maintenance, again, it is issue in this DSC and DT systems.
Very nice presentation and instrumentation. We really enjoyed that.
Yeah, thank you so much. Thank you so much, ma'am. It's my pleasure.
Thank you, sir. Thank you, ma'am. Now, I welcome you all to the valedictory session of the Faculty Development Program on recent advances in analytical chemistry. May I now request Dr. Venkateshan Jayakumar, Coordinator FDP, Associate Professor, Department of Chemistry, SVIS SVV, to present the report of 1 week Faculty Development Program. Over to you, sir.
Thank you, Divya Madam. Thank you. New knowledge is the most valuable commodity on earth. and knowledge grows exponentially. The more we know, the greater our ability to learn, and the faster we expand our knowledge base. New knowledge is acquired through experience and searching new meanings. With this word, I would like to express the FDP report, Faculty Development Program report. So, Department of Chemistry, SVIS, Sri Vaishnav Vidyapith Vishwavidyalaya Indoor conducted 6 days online faculty development program on recent advances in analytical chemistry. 7 eminent experts from the university, NITs, and industry of various parts of India were invited to share their wisdom and vast experience on the topic. The dignitaries on the stage were Chief Guest Dr. S. Balasubramanian, Professor Emeritus, University of Madras, Honorable Vice Chancellor, Professor Upender Dhar, Sri Vaishnav Vidyapith Vishwavidyalaya Indoor, and other notable persons are Dean Professor Dr. Santosh Dhar, Director SVIS Dr. K.N. Guruprasad Sir, Professor and Head Madam Dr. Kavita Sharma, Department of Chemistry. The faculty development program started on 18th April, Monday, morning at 10 a.m. with Sri Saraswati Vandana.
लगाओ ना एक मिनट फोन
Opening remarks and the program details are delivered by the Professor and Head, Dr. Kavita Sharma, Madam, Convener, and followed by keynote address of the FDP program given by the Director and Professor, Dr. K.N. Guruprasad Sir. The presidential address is delivered by Honorable Vice Chancellor, Professor Upender Dhar, and Vice Chancellor also gave a glimpse of activities which is going on Sri Vaishnav Vidyapith Vishwavidyalaya. The program progressed with the inaugural lecture at 11 a.m. by the Chief Guest Dr. S. Balasubramaniam, Professor Emeritus, University of Madras, on enhanced delivery of curcumin as an anti-cancer agent with PLGA nanoparticles. Further, the professor highlighted the importance of biodegradable polymers and advantages of controlled drug delivery. The session followed by question and answers, and the inaugural session is ended with the vote of thanks by coordinator Dr. S. Venkateshan Jayakumar, Department of Chemistry, SVIS. The second day, Tuesday, 19/4/2022, started off with the lecture of Professor Dr. K. Venkatachalam, Department of Analytical Chemistry, University of Madras, at 2:30 p.m. on applied concepts of analytical chemistry, theory and practical applications of gas chromatography. The session is ended with the discussion followed by question and answers. The third day, Wednesday, the resource person was Professor Dr. K. Venkatachalam, Department of Analytical Chemistry, University of Madras. The lecture is started at 2:30 p.m. and Professor focused on UV spectroscopy and sample analysis by classical methods. Audiences were responded with overwhelming enthusiasm to the lecture, and the session closed with questions and answers. Dr. T.S.N. Sankar Raman, Professor Emeritus, University of Madras, delivered a lecture on 4th day, Thursday, 21/4/2022. The speaker focused on analytical methods and other methods of characterization in material research. All participants reacted enthusiastically to the lecture and received overwhelming responses. The session ended with the question and answers. As per schedule, the 5th day, Friday, 22/4/2022, is organized with online instrument demonstration by Metrom India Limited. Mr. Niranjan Kodandaraman, Technical Manager, started the session with lucid presentation of ion chromatography and followed by online demonstration of ion chromatography instrument with help of technical engineer Surendran. The concurrent session of Mr. Niranjan Kodandaraman is focused on cyclic voltammetry and followed by online demonstration of cyclic voltammetry instrument with help of technical engineers Yuvaraj and Senthil Kumar. Both the lecture and instrument demonstration gave a delightful insight, clear methodology, and applications to the participants. Talk 6, the sixth day, Saturday, 23/4/2022. The session timing is 2:30 p.m. to 4:15 p.m. Title of the talk is Why Thermal Techniques is the Tool of Material Scientist and Chemist. Resource person name is Dr. Muhammad Aslan, Professor NIT Srinagar, Jammu and Kashmir. The talk discusses about the theory, principle, and instrumentation of TGA, DTG, DTA, and DSC. Further, speaker explained the applications of above said instruments. The participants were eagerly interacted with the professor and clarified their doubts when the session was opened for question after the lectures. Throughout the week, from Monday to Saturday, Zoom, Google Meet platforms are used for the faculty development program, and the session links, feedback links were shared to the participants. The registered participants were engaged in a special WhatsApp group and through by email. The recordings were being uploaded on the YouTube channel of Sri Vaishnav Vidyapith Vishwavidyalaya, Indore. And finally, we shall dedicate this faculty development program is to the father of chemistry, Antoine Laurent Lavoisier, and Acharya Sir Prafulla Chandra Ray. An important note is those participants with the 75% attendance will be issued with e-certificates by email. Over to Divya Rana Tomar, madam, please.
Thank you, sir. Thank you so much. I would like to request some of the participants to share the feedback. Ritu Patel, ma'am, are you there? They want to share their feedback. Okay, Pushpanjali Sharma, ma'am. I think they are not here. Dr. Ranveer Singh, sir, from Rajasthan. Dr. Ranveer Singh, sir.
Yes, ma'am.
Good afternoon, sir. You want to share your feedback for the FDP?
Good afternoon, ma'am.
Over to you, sir.
And thanks to all for giving me this opportunity. श्री वैष्णव इंस्टीट्यूट ऑफ साइंस के केमिस्ट्री डिपार्टमेंट के द्वारा रिसेंट एडवांसेज इन एनालिटिकल केमिस्ट्री विषय पर ये जो एफडीपी प्रोग्राम कंडक्ट करवाया गया, इस एफडीपी प्रोग्राम के दौरान रिसोर्स पर्सन ने बहुत ही नॉलेजेबल प्रेजेंटेशन के द्वारा इसका जो टाइटल है उस टाइटल को फुलफिल किया और मिस्टर निरंजन सर ने डेमोन्स्ट्रेशन के द्वारा जो एनालिटिकल टेक्निक्स को समझाया वो हमारे अकॉर्डिंग इस एफडीपी प्रोग्राम का सबसे लाभदायी हिस्सा रहा, जिसे हम लोगों ने बहुत कुछ सीखा। और इस तरह के जो प्रोग्राम हैं वो एनालिटिकल केमिस्ट्री के लिए बहुत ज़्यादा ही ज़रूरी है, क्योंकि मैंने ये महसूस किया है कि एनालिटिकल केमिस्ट्री का सबसे बेसिक पार्ट है। अगर केमिस्ट्री में हम जाएं तो अगर एनालिटिकल केमिस्ट्री नहीं है तो केमिस्ट्री कहीं भी नहीं हो सकता। लेकिन जैसे मैं राजस्थान से बिलोंग करता हूं और राजस्थान में काफ़ी डिपार्टमेंट ऐसे हैं पीजी के जहां से एनालिटिकल केमिस्ट्री जो स्पेशलाइजेशन है वो हट चुका है। तो इस तरह से अगर हम एनालिटिकल केमिस्ट्री को केमिस्ट्री के अंदर इंक्लूड नहीं करेंगे तो जो प्रैक्टिकल केमिस्ट्री है वो हमारे हाथ से कहीं निकल जाएगा। तो मेरे अकॉर्डिंग इस तरह का जो प्रोग्राम है वो आयोजित करवाकर ऑर्गेनाइजेशन कमेटी ने बहुत ही सराहनीय कार्य किया है। इसके लिए मेरी तरफ से ऑर्गेनाइजेशन कमेटी का बहुत बहुत धन्यवाद, सभी रिसोर्स पर्सन का बहुत बहुत धन्यवाद। उन्होंने बहुत ही अच्छे तरीके से जो एनालिटिकल टेक्निक्स हैं उनको कैसे यूज़ करते हैं, उनका इम्पोर्टेंस क्या है, वो समझाया। बहुत बहुत धन्यवाद सर। थैंक यू मैम।
Thank you, sir. Thank you so much. Any of the participants want to give any feedback? Sudhanshu Dwivedi sir raises his hand, so you can talk, sir. Sudhanshu Dwivedi sir. Okay. Vaishali ma'am also raise a hand.
Yeah, ma'am. A great good evening to all of you. Kavita ma'am, especially I would like to say thanks to you and your team. Vaishnav Institute has really conducted a fantastic FDP. Ma'am, really every session I thoroughly enjoyed and really we have learned a lot. But seriously here I would like to ask particularly to Professor Kavita ma'am. Ma'am, may we have any opportunity to see all these demonstrations in particularly? Because really we have learned a lot, but particularly for research point of view for our students, how can we have the availability of all these instruments so that we can show them?
Sure, ma'am. We will be sharing the recordings of all sessions with you all.
And ma'am, in Vaishno, is there any availability of any instruments, or we can actually have the visit there, or we can really take our students there?
Madam, I will be discussing to you on
Okay, sure.
personal
No. But
Sure.
okay. It was really fantastic FDP, ma'am. And practically, really, it is required, and we have learned. Thanks a lot, ma'am.
Dipankar, you wanted to say something?
Very good afternoon, madam, one and all present here. Actually, I'm really thankful to think of it because it is very busy schedule with us. But the timing, whatever given for this FDP program was very nice. It was very suit for me. Almost all, except one day it was a problem. Otherwise, I attended all these things. Second thing is that I don't really feel in physical mode and in online mode the FDP is any difference. There is more particular, more timingly in online mode, what I believe. But in physical mode, fooding center, etc., these things are very difficult things I have faced. But such type of things is not here very timingly. All peoples are already are there. So these things are very good part of our online such type of FD program. And I request the organizing committee and you, Madam Kavita Sharma, Madam, you must organize such type of things at least once or twice in a year. It will help most of the people from various part of the country, though they are not able to attend physically. It is a nice initiative, and Corona has given us something positive from that point of view. I think it was almost all very fantastic. Thank you again, one and all, you associated with this type of a great program. Thank you, madam.
Thank you, sir. We are also agree with you. Sure, we will be organizing time to time such kind of programs.
Thank you everyone. Can we proceed, ma'am? Okay, now I request Dr. K.N. Guruprasad, Director SVIS, Sri Vaishnav Vidyapeeth Vishwavidyalaya, for concluding remarks.
Thank you, Olivia. Guest speaker today in the Faculty Development Program, Dr. Mohammad Aslam, Professor, Department of Chemistry, NIT Srinagar. Dr. Kavita Sharma, Head, Department of Chemistry. Dr. Venkateshan Jayakumar, Coordinator of the FDP, and the participants. We are in a profession as teachers and as scientists and as researchers, a profession where a continuous learning process is part of profession. And this kind of programs on faculty development, like faculty development program, is organized with that purpose that We will learn more from the experts who are in this field and who are also fortunate enough to be in the national institutes where more deeper research is possible than the smaller institutes. So that the teachers who are in other institutes are also exposed to the kind of research, the kind of instrumentation available, and the kind of advances which have been made in any specific area. Like I was just listening to one of the feedback comments where they were inquiring whether what kind of instruments do we have where they can have a practical exposure to that. Now, that is what becomes necessary for any research in science, that scientific research, particularly of experimental science, is related directly to the availability of the advanced instruments. You can do more deeper research depending on the kind of instruments you have. So those institutes which may not have this kind of facility can avail the facility in many other national institutes and may have to outsource some of their research work. And so we need to explore that possibility also. We should not be discouraged by the non-availability of instruments, because that should not stop our research. Our effort is towards a learning process, to learn more and more and to do more and more research, irrespective of the hurdles with which we meet. Hurdles are there everywhere in every field, and we should not get bogged down by the hurdles and go forward with our aim of doing more research and going deeper into the subject, because the learning process never ends. Our career may end, but the learning continues. And more and more, especially in the area of analytical chemistry, more and more new instruments will be developed for more precise analysis and to help us understand the subject in a better way. So I'm glad that most of the participants have got the benefit of this faculty development program, and I also thank all the resource persons who have participated in this and who have enlightened the other participants with their knowledge. And I hope we will continue to maintain our relationship with all the resource persons and take their guidance in furthering our learning at our institute and also at all other institutes from where the participants have joined. With this, I thank everyone. Over to you, Divya.
Thank you, sir. Thank you so much. Gratitude is the fairest blossom which springs from the soul. Every celebration is an experience. The external fades away and the internal lingers and echoes in the most depth of our heart. We are reminded that events like this, one of the milestones on the journey of life and reminders of the God fidelity also. Now I request Dr. Kavita Sharma, convener FDP, Professor and Head, Department of Chemistry, SCIS, SVVV, to propose words of thanks.
Thank you, Divya. Gratitude makes sense of our past, brings peace for today, and creates a vision for tomorrow. Respected Dr. K. N. Guru Prasad Sir, Director, Shri Vaishnav Institute of Science, Shri Vaishnav Vidyapeeth Vishwavidyalaya, Indore, Dr. Muhammad Aslam Sir, Department of Chemistry, NIT Srinagar, Jammu and Kashmir, Speaker of last session of this FDP program, Dr. Venkateshan Jaykumar, Coordinator of this Faculty Development Program, and dear faculty members. I am Dr. Kavita Sharma, Professor and Head, Department of Chemistry, Shri Vaishnav Institute of Science, Shri Vaishnav Vidyapeeth Vishwavidyalaya. Take the opportunity to put all my gratitude into words and to propose a words of thanks. We have been fortunate to have renowned identity from academics, industry, and other frontier areas. First of all, I would like to propose hearty vote of thanks to eminent chief guest Dr. S. Balasubramanian, Professor Emeritus, Secretary, Royal Society of Chemistry, University of Madras, who is, spite of his busy schedule, accepted our invitation and graced the faculty development program. And I feel immense pleasure to thank all the resource persons Dr. K. Venkatachalam, Professor, Department of Analytical Chemistry, University of Madras, Dr. T.S.N. Sankar Narayan, Professor Emeritus, Department of Analytical Chemistry, University of Madras. I place on record our deep sense of gratitude to Mr. Niranjan and Team Metron India Limited for the excellent presentation and online demonstration of instruments. All of us were benefited by this presentation. I extend grateful thanks to Muhammad Aslam Sir, Professor, Department of Chemistry, NIT Srinagar, for the captivating and wonderful presentation, sir. Thank you very much. At the outset, I am happy to thank Honorable Vice Chancellor Dr. Upinder Dhar sir for continuous encouraging and supporting all our efforts. My heartfelt thanks to Director SVIS Dr. K. N. Guruprasad sir for valuable insights and constant motivation. I also extend wholehearted gratitude to Association of Chemistry Teachers, professors, faculty members of Sri Vaishnav Vidyapit Vishwavidyalaya, and professors, faculty members of other universities, colleges. My heartfelt gratitude to organizing committee, especially to Dr. Venkatesan Jaikumar sir, coordinator faculty development program, technical team, and all participants and everyone who have contributed for the success of this faculty development program of Sri Vaishnav Vidyapit Vishwavidyalaya on recent advances in analytical chemistry. Thank you one and all once again. Thanks. Namaskar.
Thank you, ma'am. Thank you very much. May I now request the gathering to raise for the national anthem?
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
भारत माता की
Jai. Jai.
Thank you. The end of the story is a new beginning of many others. So I shower my heartfelt gratitude to all the professors and everyone present here for their wholehearted support rendered in the success of this valedictory session. Thank you very much. Thank you, Mohammed sir.
Thank you.
This is Divya Rana Toma, your host for the day, signing off. Until we meet again, take care and have a wonderful year ahead. Thank you, everyone. Have a wonderful and fun-filled evening. Thank you all. All of you are requested to fill the feedback link for the certificate, and you will get the certificate within a week. And all of you are requested to remain in the WhatsApp group, so you'll get the information regarding the certificates. Thank you all.
Thank you. Thank you, Divya.
Thank you, ma'am. 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 Thank you. No, ma'am. Yeah, I